Welcome to Embedded. I am Alicia White, here with Christopher White. Our guest this week is Dr. Victoria Serrano, and we're going to talk about Panama, education, disability, and who knows what else, maybe PID loops.
Hi, Victoria. Welcome.
Hi. It's a pleasure for me to be here with you. Thank you.
Could you tell us about yourself as if we met at an IEEE meetup that had elevator talks?
Okay. I'm Victoria Serrano. I'm a professor at the Technological University of Panama in the Chiriquí Regional Center. And I've been working there for more than 15 years. And I am also an Arizona State University alumni and a STEM promoter, a STEM programs promoter, and a passionate about science, technology, and engineering education.
All right. That gives us a little bit to work on, but we have many more questions, particularly about the STEM education. First, we're going to do lightning round. And you've mentioned you're a little hesitant about this. Let's see how it goes.
Okay. Which is better? Arizona State University, University of Arizona, or Grand Canyon University?
Of course, ASU. It's the best one. For me, it was a great opportunity to be there. I studied there for more than 6 years. So I spent a lot of time in my education, getting my master's and my PhD at Arizona State University. And it gave me not only the foundation for an electrical engineering specialization, but also gave me the tools to contribute with community and change the life of many people with the projects that I develop worldwide.
You mentioned that your university is in Panama, which is a point where you can get to both oceans. Which of the two oceans you can get to is your favorite?
I prefer to go to the Caribbean Sea just because it's way beautiful. But both oceans also give you a lot of different places to explore. And you actually, the great advantage of Panama is that you can go from one ocean to the other one, maybe in about 3 hours. So even in one day, you can explore and get a view of both of them and feel energized.
Could you bicycle from one to the other?
Maybe, but it's going to take you more time because 3 hours is just by car. So in bicycle, I have never tried, but it's going to take you a lot of time also because you have to go through the mountains. So it's going to be like up and downs. Yeah.
Do you normally complete one project or start a dozen?
When we talk about projects, especially because you have to develop from the spark that you have about something that you want to do, I try to get all my attention to one of them. I may have other tasks that I have to complete as well, but they don't demand a lot of my time. So when we talk about project, I try to take one at a time just because I want to get the best of it. And if you want to do it, for me, it's just better just to keep all your attention to one of them, to complete it, and then to continue with the other one.
Favorite fictional robot?
My favorite one? I don't remember the name, but it's a one that they created even a movie, and I think it's just because it brings also some emotional part, and so that makes you feel like it's not only a robot that can make something, but it makes you feel like connected with your emotions. So that's why I like that one, but I don't remember the name right now.
Wally.
Yeah, that one, Wally.
Okay.
Don't you think that it makes you feel emotional, like when it's trying to do different tasks, and it connects with you, like with your emotions, with what you feel and how you feel it, and that's probably my favorite one. That's why.
So you did your education at Arizona State University.
Lightning round is over.
Oh, yes. Sorry. You did your PhD at Arizona State University, and your thesis was in PID controller tuning and adaptation subject to quantization effects. And I have to admit, this sounds super interesting to me, but I think I might be one of the few. Could you describe it a bit?
Yeah, and this was a project that we were working with another professor in another area, which was not control system, but he was more specializing in the power electronics area. And the idea was just to study uh, what what were the effects when we were having different scenarios when the different devices of the buck converter were just getting degradation. Because over time, I know it should take some time, some considerable amount of time to degrade. But when we talk about devices such as inductors, capacitors, or whatever other device, they don't measure the same level as when they were new. So what we were trying to do with this project was just to describe the different scenarios when they were changing their values, for example, 5%, 10%, 20%, like 5 or 6 different scenarios. And then we were trying to what we did was to design the controller for that specific scenario, and then we were just choosing the right controller depending on the scenario based on it was like a rule in which we were choosing the right one based on that rule. You had to minimize a specific parameter just to choose, okay, this is the perfect fit for that scenario. And that's why this was adapting, because when we had the different scenarios, we already designed the different controllers, but then we had to choose the best one based on that parameter that we wanted to minimize. I don't know if I explained what I did with that specific research.
Let me see if I understand. You were tuning a buck converter that was degrading over time because it was aging, and you had a controller that would make the output be the same, but it was a set of several controllers.
Exactly.
That you chose based on the heuristics, the characteristics currently in the system.
It was like a metric that you had to fulfill so that you could choose the specific controller. So, but that if we were not getting close to that minimum value of that metric, then we had to choose the next controller.
Okay.
Yeah.
But that was, I liked that controller discussion, your dissertation. But what I should be asking you about is education in STEM, because that's more what you do now. That's science, technology, engineering, and math. But the technical education, how are you involved with that now?
Well, I would like to tell you that I started when I was studying at ASU. And the way that I started was because I was getting involved with student organizations at my university, and they were having some outreach programs in which they were trying to involve high school students or even middle school students, and uh, they were trying to encourage them to get into university, because you know that the population, especially when we talk about minorities in the United States, not most of them go to the university. So that was our first goal, just to show them that this was a great opportunity if you invest your time during those 4 5 years in average, in which you can get a degree in engineering that pays off at the end of the day. So I realized that this encouragement that you were giving students, that was showing them at a different path, completely different from what they were usually doing. So I realized, like, okay, if you are doing this for the community here, I I also wanted to do the same in Panama. So that's why I applied for a call from IEEE, and then we got the funding just to develop a very short uh, outreach program in Panama, and that's how it started here. But then when I got here, because I finished my studies in the US, I got back here, and I I started doing more outreach programs here with different schools, and we already kind of created a community, because every time that I am trying to develop a new program, the teachers are like, "Okay, we're up. Just let us know when we're going to start." And that has changed not only the lives of the students who get involved in those projects, but also in the way that they see uh, what they can do for others. And as a result of that, we have had students who have participated in our projects, and now they are engineers. Now they are also studying engineering. And the reason why they started doing that was because they realized, like, okay, with engineering, we can also do a lot of things to change the lives of other people. So that's really rewarding for us.
The ability to change the lives of other people is definitely one of the things that brings people to engineering educations. What do you see pushing them away from engineering?
Honestly, I think it's math, just because they feel it's like a problem that they have to overcome, or all the time that they have to study at their levels. But when you try to show them, like, okay, what you can do with math, and that allows them to see that it's not only like a trouble that I have to deal with, but it's also a tool that I can use to develop solutions for to help other people. For example, when you show them um, 3D design, which is one of their favorite ones, probably if you tell them, like, okay, you have to measure a length, and you have to draw a cube, or you have to calculate uh, uh, a distance between 2 points, they don't see that excitement about doing that. But when you show them what they can do with that, and when you tell them, like, okay, now what you're designing on the computer, you can materialize this into a product or a, or a, or something that can be a solution for someone. Now they started doing like, okay, math maybe not my friend, but it could be my partner that I can do that I can use to develop wonderful things.
Math is a tool.
Yeah.
And I think doing more and more robotics over my career has made it so that I finally understand trigonometry. I didn't know how I was going to use that in high school, but now a lot of my life is spent with ATAN and all of the sines and cosines.
Yeah, and also when I have realized that robotics is something that it's very exciting for children,
Mm-hmm.
and that's why most of the projects that I develop with students, with either middle school or high school students, involve the use of robotics, because when you tell them as a theoretical thing, okay, if you type this or if you drag and drop this block, that makes you move a motor that is like the hand of a robot, for example. But when you tell them, you only tell them. But when they do it and they realize that what you're telling them is actually working, it's just awesome for them. You can see in their eyes that they get really excited when a robot move, and that's very satisfying because you are actually doing something for that new generation that can become the future engineers of our system.
The physicality of robots, that you can write software and change the physical world, has always been a draw to me. Is that part of what you see in your students, or are they okay with just software?
No, they usually like to mix both things, not only the software, because when I in my personal experience, when I tell them only, okay, if you could code this is gonna calculate something. But if when you see them connecting all the parts and getting them to move, that's really exciting for them. It is.
We've both mentioned STEM, which is the catch-all for technology education. But then there's the other acronym, STEAM, which is the science, technology, engineering, arts, and math. How important do you think the art is in that?
I do believe this is really important just because art makes you activate the other part of your brain that balance the scientific part with the other part, which is more related to creativity. Um, in my personal experience, since I've been playing the piano since I was maybe like 8 years old, I know the importance of including art in everything you do. I am not a pianist. I am not a professional pianist, but this has always been with me when I am studying, and that also helps me to balance when I get, for example, stuck. When I am trying to develop a new code or to try to develop a new method to calculate something, but also this helps you to balance that life, that scientific life, with the creativity that you have to develop to bring new solutions to whatever you are facing in life.
You not only do outreach for STEM education, you also are involved with the idea of STEM education for people with disabilities. Could you tell me a bit about your work there?
Yeah, I started working with engineering education for to develop solutions for the people with disabilities, because I had the opportunity to study in the US, and I knew how everything worked there for people with disabilities. For example, we could have doors in which you only push a button and then it's gonna open for you so that you can get into the place. But we don't have something like that here in our university. Uh, Most of all of the doors that are in the university are that type of door, hinge doors. And if a person comes into the university with, for example, a wheelchair, they cannot go by themselves to even the restroom. They always have to wait for a person who helps them, because they cannot even open the door. How they are going to go into the restroom if they don't have the possibility to open the door? And when I saw that, I was like, okay, if I saw that solution in another part of the world, I would like to have something like that here. And I know it's very easy just to think about a solution that you can buy online and just bring it and install it. But for me, it was more important just to get people involved in the solution and let my students learn that they could provide that solution. And it was very interesting for me, because when I brought that challenge to my students, I was like, okay, let's go some brainstorming. And what do you think we could do to provide that solution to open the door automatically? And one of them brought the idea of using the motor that the cars uses to open and close the windows, because that should be a motor that has enough power to push a door, which is something that is very heavy. And they started working on that, and they made it work, because and that's why for me it was just very important to integrate the solutions that you could have with engineering education, but also with the problems that people with disabilities face every day here.
Your example of a door that opens with the button, I'm familiar with them. And they're very handy for people who use wheelchairs or who are on crutches, which I've done that. And they're also useful for people who are carrying boxes or just don't have their hands available. There are many technologies that were initially adopted because they were nominally for people with disabilities, but they turn out to be useful for just about everyone.
Yeah, and what I was one of them who was not most of the time, but several times carrying a lot of things in the US when I was studying. I was bringing my books, my backpack, my lunch bag, everything in my hands. So I didn't have it available. I didn't have my hands available to open the door. So for me, it was very handy just to have a button to push it and to be able to enter the room. I'm very familiar with that. So as you said, yeah, this is not only for people with disability, but for us, for people who are carrying a lot of things. And also, we have to have something in mind. A person, maybe it's in a wheelchair, maybe for the rest of their lives. But some people are having situations in which they cannot open a door, and that's something temporary. And we never think that we don't think that we are going to be in that situation anytime. Hopefully not. And hopefully we are always healthy, but you never know. And if you face that situation in which you need something to be open for you, then you're going to remember, oh, I would like to have this button just to be able to push it and to open the door so that I can get into the room, for example. So yeah, we have to think in the solutions that we can provide to people who are less fortunate to not be that healthy at that moment, but we have to think and try to empathize with those people.
Do you find that your students get that they really understand the empathy, or do you have to explain it to them?
No, I think the last project that I worked with engineering education to try to bring solutions for people with disability was very touching. Not only because, okay, it was nice just to teach them how to do 3D printing, 3D design, how to program an Arduino board or things like that. But also because they 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 were relating to what other people were feeling, especially people with disabilities. And one of the stories that I can bring up is that one of the students who was participating in that project, one of the weeks that we were meeting, she was like, "Oh, now that I went to that specific store, I realized that there was a toy that had um, the dots to for a person who's blind to be able to read it."
Oh, Braille. Okay.
And the braille, yeah, the braille. And they, I was like, okay, this is really nice. We are getting what we really want with this project, because it was not only about teaching them Arduino or 3D printing, 3D design, or how to code, because that's something that you can even learn online with a YouTube video, maybe. But that feeling in which you are now realizing that, okay, now she's realizing that this braille system is important to include it even in toys that are for a regular person who doesn't have any disability. So for me, that was something that was really touching. And even when they were developing their prototypes, to be able to print the signs with braille system, they were being very careful with how they were placing the dots, because they knew that if they placed a dot incorrectly, that was going to say something completely different from what they were trying to say. So that for me was also very touching, because you could see that you didn't have to explain how to empathize with another person, with a person with disability. They were just getting the feeling. They were just getting the real idea of empathy.
Do you get any pushback or disagreement on this sort of work?
No, I think this was a very good project, actually. And the good thing about this project, when we developed that in Panama, was that we also had the company of the teachers of each of the schools that were participating in the program. So that was also a very good thing, because they could replicate what they were learning at the university in their own schools. And actually, some of them even started replicating the same thing. So that was like a multiple factor that, okay, what they learned, now they are teaching them to others, to other people.
That's always so important.
Yeah.
Helps you understand better when you've taught it to someone else.
Yeah, definitely.
Okay, this is sort of a weird question. Listeners of the show may understand where I'm headed with this, but I'm going to just come out with, it's kind of a weird direction right now. In 2019, you won the IEEE Meritorious Achievement in Outreach and Informal Education. Could you talk about what that is and what you were nominated for?
Yeah, well, that's one of the awards that the Education Activities Board created several years ago, just to highlight the work that people have done in different parts of the world, in try to teach or to bring outreach programs, but as an informal education. So that means that we are not necessarily in a classroom or at a university or a school, but in different places in which you are trying to bring education. So I got nominated in 2019 because I had participated in outreach programs, not only in the United States but also in Panama. And we developed some projects not only uh, in schools, but also, for example, in fairs or at a space next to a church, for example. And then we were providing those programs to try to encourage students to get into STEM. And it is prestigious. I think it is very prestigious because when we talk about IEEE, is especially for the electrical engineering field. I think for us this is top. So once you get an award from IEEE, that means a lot, and that also opens a lot of doors for me once I got it. Um, because many people didn't know what I was doing here. And once I got that award, I started getting invitation from other mm, from other even private sector, um, that were inviting me to be not only to be part of their programs, but also to give award uh, as an advice to what we can do or how we can improve this. So that was thanks to this award.
So it has some effect with raising your profile.
Yeah.
Did you care about the external validation of it? Someone saying you did a good job? Or was that just not important?
For me, it is important, but also, and I think it makes you feel like, okay, it is worth it. All the sacrifice that I'm doing, all the extra effort, because those programs are usually programs that I do in my spare time. So if uh the first reward that we get is a personal reward that has something that it doesn't have any price in life, but also being recognized by some other people also makes you feel very, very well. And it also makes you elevate your profile, because now people see people see you as somebody who can give an advice or can give a, a good point of view of how we can improve this. And that's why this is really important.
How does STEM outreach in the US differ from that in Panama? I mean, for me, it seems like they would be totally different, but I don't have a good sense at all. Can you help me with what Panama is like with this?
I think in Panama, it would really depends on the region also.
Mm-hmm.
Because I'm maybe like 250 miles of the main city. And here, especially when I talk with teachers and I want to do, for example, outreach with different schools, they usually tell me yes to everything. So, and they are always just waiting for an opportunity to get involved with these programs. And 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 that's is something good because usually when you have to get permissions from their directors, you get their approval very easily. But if you, for example, I think in the US, in that sense, it could be it could be more rigorous in the sense that all the approval that you have to get through the different like supervisor or directors or things like that. Maybe in that sense, it could be, I think, it a little bit easier here.
Are the students different? I mean, you've worked with elementary school kids in both locations. Are they different, or are they at the core the same?
I think they are pretty much the same in the sense that usually students who get involved with outreach is because they feel passionate about robotics, about coding, about learning new things. And in that sense, they are pretty much the same because when we talk about outreach in the US, they are kids who want to learn something new. Like, okay, I have heard, for example, about coding, about Arduino, about robotics, about and they want to learn. So they want something who can guide them. And in that sense, they are pretty much the same as well here.
Do you also look at race and gender diversity issues, or is it just open to everyone and everyone is encouraged to attend?
They are encouraged to attend, but I usually try to get girls involved. So when I am organizing those programs, I tell the teachers who are involved with the program, please bring at least 50% of girls because we want them to get a taste. I mean, I would like them to become engineers as well. But if they don't do, I will at least I would like them to take a take a taste of what engineers looks like.
Going back to the Outreach and Informal Education Award from IEEE, how did you get nominated for it? Did you do it yourself? How did that work?
Oh, I was nominated by another lady who's part of the IEEE Panama section, who knew what I was doing with outreach here in my region. So she was like, okay, I think this is a great opportunity for you to get awarded if you get selected for this award. So she was aware. I mean, Panama is but it's a very small country. So especially when we talk about IEEE, usually when you start doing a lot of things, other IEEE members know what you're doing. So this was something very, very good to know, and she was aware of that, and that's why she got me nominated.
Did you do anything nice for her?
Yeah. I gave them a thank you note with a flower because I mean we have to be thankful in life, not because you are expecting something to something good to be back to be back at you, but you have to be thankful. That's it.
Going back to outreach, you mentioned Arduinos and robotics. Do you have a kit you used, or did you put one together when you go visit students? And do you have ones for different ages?
And I usually use the basic one, which is the Arduino Uno, and I don't really have a kit. I mean, I put I when I create the program, I know how to start from the very basic, which is just to lighting up an LED, and to more advanced, just to read information from a sensor, for example, or to move a motor. So what I do just is to make a list of all the devices that I'm gonna need for all the sessions, and then I bring them all together for the group of students that I'm gonna work with.
Do they get to keep them?
And they actually do, because one of the ideas that when we develop these programs is just that they can replicate what they learned at the university in their own schools. So we don't want them to have an excuse like, okay, we cannot do it because we don't have the equipment. So that's why we try to use low cost equipment so that they can also replicate it in their schools, and we donate them part of the equipment so that they can start. They can have a starting point from there.
I was going to ask how this program feeds back into the schools, because it's great to have these programs, but if it's not ongoing, or if it's not replicated in schools, or is not, the kids don't persist with it, then it's less likely to be successful. So how does that work?
Yeah, that's one. That's why one of the key points that I ask when a group of students is going to participate is just to get one of the teachers involved. And if we are having, for example, once a week, a meeting once a week, they have to be there with their teachers, because otherwise, I mean, they're going to graduate eventually. They're not going to be at school anymore. So how are we going to keep this sustainable over time? That's why we have to have our teachers involved, because they at the same time that they are also learning, and they are also getting all the hands-on experience, they can also do it with other students at their schools. Because also when we work with those students, I mean, they are not like 30 students from each school, because we don't have the capacity. We don't have a room enough for more than 100 students. So we only bring maybe like 6 or 8 students per school. And that's how they can also replicate the same experience at their schools after they finish their project.
Okay, so in Arduino Uno, you can do a lot of different light things because, as you mentioned, it has LEDs on it. To do more motor things, you need a motor board and some motors. Do you use one of the standard motor boards, or do you have them wired up directly?
Yeah, we use the one of the motor shields, which is already just ready to plug in onto the Arduino Uno, just because it's more convenient for a short program. If we had them, if we have to build everything from scratch, it's gonna take more time, and probably we would not be able to cover all the topics that we want to develop with them.
Of course not. And the motor shields are a good idea because if you hook the motors directly to the Arduino, you're going to blow up the Arduino eventually.
Exactly. Of what the motor shield does, for example, but we don't get into details because that's going to require more specialized topics, like knowing about, I don't know, maybe MOSFETs or transistors in general. So we don't go into a lot of details with that. So we explain them why we need the motor shield and why we cannot connect the motor right into the Arduino, for example.
And then do the students have their own computers or do they have computers through their school? How does that work?
We have had two different programs in which, for example, one of them, they were using our computers at the university because they were coming to the sessions at the university. They were using our computers. And in the second version, I think second and third version, they were bringing their own computers just because they also wanted to do something extra during their week when we were not meeting, and they wanted to work a little bit more, and so that's why it's so that they didn't have to wait until we meet up again so that they could do their work.
And then the students make small projects. Is that right?
Yeah.
Do they all end up making the same small projects or do they have some freedom on what they're going to do?
Well, usually they do the same thing, just because when we develop those projects, they are they are participating as part of a funded project.
Mm-hmm.
So when you write the proposal, you have to specify everything that you are going to do with them. So the way that we developed the proposal, we said, okay, this is what they're going to do. So we have to keep in that scope. But what they do is that, for example, in one of the projects that we developed, they got into a competition and at the end of the program. So they all had the same robots, but we didn't we gave them the basic coding, and then we told them, like, okay, now you can improve your code. What can you change to improve it? And that's how they started just improving them, to be able to, for example, to reach the final line in the shortest time. So they all do, for example, if we are talking about robotics and they were doing a robot, all of them have their same robots, but they could tweak a little bit if they wanted to change their code, or if they wanted to change the position of a sensor, for example, things like that.
I like when students start to tweak things and realize how much freedom they truly have. Do you show them some of the more grandiose Arduino Uno projects? I mean, there are so many people who've done amazing things, but some of them are a little overwhelming.
Yeah.
And yet knowing that all of that code is out there and repeatable, replicable.
Yeah. The good thing is that when I start doing, for example, this types of projects, I show them what other people have done with what they are going to learn. And of course, I show them videos in which people have done amazing things with Arduino. And that's just to try to open their minds so that they can see like, okay, now this is getting this is getting exciting because um, I I can do, if I apply what they are going to teach me, I can eventually do all those things.
Do you provide your lesson plans to the teachers for when they go back to the students, to the schools?
Yeah, because the idea is just that they can replicate what they are receiving at the university, so they could have a starting point. But I have to admit that some of them are actually having also robotics clubs
Mm-hmm.
in their schools. So that also helps with whatever we are teaching them. And also sometimes they are even uh, giving us feedback on things that we are not aware of. For example, okay, professor, this is um, one new device that came up, for example, and probably I wasn't aware of that one. So it's a very, and the good thing is that we still nowadays we keep communication because that's a way that we can get in touch in, for example, if I have a new program or if they have also even uh, news about the students who participating who participated in our programs, and now they are, for example, studying abroad, or now they are doing another project, or now they are replicating whatever they learned at the university at their schools.
How do you, or have you had to deal with students who are interested and excited to learn about electronics and curious, but also maybe a little bit afraid of breaking something or doing something wrong, or I don't know, electricity, motors and things and wires. And if you haven't experienced it before, sometimes there's a feeling of, oh, I'm going to break something or damage something or shock something.
Well, I have a phrase with my students at the university, for example, when they blow up something like a capacitor or something, I was like, okay, this is impro of knowledge. and then they already they already know, and when they do something probably that is not correcting their connection, they are like, okay, this is pro knowledge, professor. And I think you have to give them confidence. I mean, it could be maybe terrifying when you have never done a connection and you don't know what's going to happen, but you have to give them confidence. I think that's the most important thing because, uh, I mean, we are always learning something new, and who haven't felt afraid of something that you don't know if this is going to work. I mean, everybody. But if you make them feel confident, even if they make a mistake, because mistakes helps you to learn that the next time this is not the right way to plug in something, for example, when we talk about electronics. But that doesn't mean that every time that you do it, it's gonna fail. It's just gonna be a learning lesson.
Mm-hmm.
That's it.
When I think about online tutorials and curriculums for outreach or intro to STEM courses, I, of course, think of the ones in English because that's my native language, but yours are in Spanish and you have posted your lesson plans.
You mean posted like on a website or something?
Yes.
Well, the lessons plans for outreach, I mean, they have been shared with for example, the teachers who are participating in the different outreach projects. But I don't think I have it on a website or so.
You you have your materias page on your university website, and I speak only enough Spanish to know that this is a lot about electronics.
Yeah, what I have done, I really have done is just, especially when we started pandemics, I started creating a lot of videos on a YouTube channel regarding the different problems that they could solve especially in the subjects that I was teaching at that time. It's very interesting because this is open for everybody, not only for my students. Of course, for my students, I was sharing them the link, but since this is public, I mean, it's open to anybody. I have had questions from people who I don't even know. And they are asking like, okay, why this result is multiplied by 16, for example. And then sometimes when I get the time, I try to answer, but I mean, not all the time, but sometimes I do. But yeah, this is actually open for everybody. And yeah, if you go into that channel, you are going to find probably a lot of problems about physics too, electromagnetism, but also about power electronics, control systems, or how to get a transfer function, things like that. I mean, it really depends on the subject that I get assigned every semester, and then sometimes uh, I develop new videos for them to see the how to the step by step how to get into the solution.
Clearly, my cyber stalking was insufficient. I did not find your YouTube channel, so I will have to ask you to send that to me so I can put it in the show notes.
Yeah, it's just because it's not by Victoria Serrano. So if you are gonna try to find me as Victoria Serrano,
Exactly.
you are not gonna find it. It's just because I created like a website for the other programs that I was also doing outreach. And I was like, okay, this is a mobile center. And then I created the YouTube channel for that mobile center that was doing outreach in different places. That's why.
That makes sense.
Yeah. Yeah.
Victoria, it's been wonderful to talk with you. Do you have any thoughts you'd like to leave us with?
Yeah, I would say, because probably some people who are going to listen to this podcast are related to science, or at least they like it. They like to listen about people who are doing science, technology, engineering, that you are always going to find difficult situations in life, and especially in the engineering field. But I would say never give up, because that's part of life. That's part of the challenges that we are always going to find. So I would say that just try and persist and be resilient, because that's the way that you are always going to succeed al final, to the end.
That is some excellent advice. Our guest has been Dr. Victoria Serrano, engineering professor at the Technological University of Panama, Chiriquí Regional Center.
Thanks, Victoria.
Thank you so much for everything and the opportunity.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon and Ko-fi supporters for Victoria's microphone. And thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. Oh, wait, I have a few more thank yous here, actually, because we were nominated for the IEEE EAB Meritorious Achievement in Outreach and Informal Education. I know it's a bit of a mouthful, but it's there. Mark was fantastic in retrieving this idea from the dustbin and actually putting it together and getting everything sorted. So big thank you to Mark. Also, thank you to the folks who wrote endorsement letters, including David, Aaron, Scott, Francesco, and Patrick. I can't even say how honored I am that you were all willing to take the time to tell people that you appreciate the show. So thank you. Thank you very, very, very much. And now a quote to leave you with. Sighted or blind, deaf or hearing, each of us holds just the tiniest fraction of the world's wisdom. Admitting we don't know everything will help us on this trek for knowledge. That's a quote from Haben Girma in Haben, the Deaf-Blind Woman Who Conquered Harvard Law. It was a really good book, very eye-opening.